We're going to look at one more. And this one's really going to set the stage for what comes next. And the reason is because of this log function. So we'll talk about that in a little bit. But first, let's just think about how we would actually differentiate this thing, just kind of as we've been doing, just kind of going through identifying which rules we would need to use. So what's our function? It's f of x equal to the natural log of x plus 1 over the square root of x minus 2. And when we look at this function, whenever we're presented with a function to differentiate, you want to identify, well, what is the main operation? And so when we look at this, if we were going to differentiate, the first thing we would have to differentiate through is this natural log. So we see that this is actually a composition. And we would have to use chain rule. So what's our outer function? Well, just spoiled it. It's the natural log. And then what's our inner function? Well, it's that fraction, x plus 1 over square root x minus 2. And so whenever we have a composite function like this as our kind of our main operation, the way we differentiate a composition is with chain rule. Now we also referred to this, gave it a special name. So whenever our outer function is the natural log function, sometimes we also call this the general log rule when we looked at chain rule. So how would it work? Well, we start by differentiating our outer function. So what's the derivative of natural log? Well, it's 1 over, and then it's 1 over whatever was originally inside the log function. So like derivative of natural log x would be 1 over x. But here, it's going to be 1 over our entire inner function here. So it's going to be 1 over x plus 1 over square root x minus 2. So that's the kind of the first piece of this. That's the derivative of our outer function. So derivative of the natural log, it's 1 over whatever was inside. And then we multiply that by the derivative of our inner function. So we take our inner function, the piece that was inside the log function, so in this case the x plus 1 over square root x minus 2, and we multiply by its derivative. So we need to differentiate this fraction, and that's going to require quotient rule. We're not going to finish this one. So there's kind of first derivative rule we had to use was quote chain rule. Next, we're going to have to use quotient rule to kind of differentiate our way through this fraction. And then once we apply the quotient rule, we also have this square root function to differentiate through. So that square root function down here is also going to require a special derivative rule. Another chain rule or general power rule. So there's actually going to be kind of 3 derivative rules that get thrown around here. The first chain rule that we have to use to differentiate through the log function. Then the quotient rule that we have to do to differentiate our way through this fraction. And then we have the square root function that we have to differentiate through. And that's going to require another chain rule. So you can do this one. It might be good practice to finish this. But as we're going to see, this log function is really going to kind of simplify. We can actually simplify this function. So there's properties of the log function that really simplify down multiplication, division, and exponents. So we're going to see that next. So you can finish this for practice. We're going to finish it using some other method in a little bit. So we'll look at this one again. But really what's going to happen is this log function becomes really important. So we'll see that next.